Hi there, I'm Abby. I'm with LDV Capital. We invest in people building businesses powered by visual technology. We thrive on collaborating with really early stage teams that leverage computer vision, machine learning, and artificial intelligence in order to analyze visual data. This is our series, Women Leading Visual Tech. The purpose of the series is to highlight some of the top ladies whose work in visual technologies are revolutionizing business and society. We hope that by bringing together entrepreneurs, investors, technologists, and researchers, we cultivate a community of women and underrepresented genders in visual tech who are willing to help each other succeed. In this interview, I had the pleasure of talking with Dr. Karen Panetta. Dr. Panetta is an electrical and computer vision engineer. She's an inventor and the dean of the graduate education for the School of Engineering at Tufts University. Her research areas include artificial intelligence, machine learning, and automated systems, simulation, and visual sensing systems. Dr. Panetta develops signal and imaging processing algorithms, simulation tools, and embedded systems for application for robot vision and biomedical imaging applications. She's won a number of awards in excellence for research, social impact, teaching and mentoring, ethics, and engineering education. She's the recipient of the Presidential Award for Excellence in Science, Math, and Engineering Mentoring from U.S. President Barack Obama. She also founded the Nerd Girls program, which encourages young women to pursue engineering and science. Dr. Panetta is the editor-in-chief of IEEE WIE magazine, and she's the co-author of the book, Count Girls In. Her passion is utilizing her engineering knowledge for the benefit of humanity. Dr. Panetta has advised world leaders and led humanitarian projects around the globe to change lives, help communities thrive, and to protect the environment. I hope that you enjoy this conversation almost as much as I did, talking about how there's magic in engineering and that creativity cannot be left out of STEM. Let us know what you think. So hi, Karen. Thanks so much for joining me on Women Leading Visual Tech today.
Thank you so much for having me. I'm really excited to talk to you.
Yeah, it's such a pleasure to have you on here. One of the ways that we typically start out is kind of just by asking you to describe what you do to a 2-year-old in really simple terms.
Well, I actually had to because I had a 2-year-old at one time. I talk about what I do, engineering and science, as the magic that makes things happen that looks to other people like magic. And for kids, we could start out and I say, you can take a bunch of ingredients and when you put in the oven, it transforms into cupcakes. And that's the magic of science, is that there's ways for us to put ingredients together and use our imagination to make new things possible that we thought we couldn't do other than by magic.
That's exciting. I love that. Like that this is the magic of the way that the world works that you're trying to figure out, and you're trying to, learn more and more and delve into what really makes that magic work. How was it exactly that you decided to go into electrical computer engineering?
I'm going to be truly honest.
Yes.
I had no clue what electrical computer engineering was. It was just the computers were coming out, and my dad said to me, you have a very expensive shopping habit and you are going to need a career that you can afford to your bad habits. And I don't want you to be dependent on anybody else. I want you to be financially independent. So he essentially chose it for me. He was disappointed that I didn't become a civil engineer, but computers were coming out and I loved programming. I thought it was so easy. I thought it was fun, but that wasn't enough. I wanted to know what was inside the box, the magic. I wanted to know how to make that magic myself. So I learned computer architectures. But even after I graduated with a computer engineering degree from Boston University, I said, well, computer engineers build computers. That's what we do. So I did become a computer architect. And afterwards, I did that for many years. And that's where I first got into simulation. And that's when I started to think, wow, there's more things I can do with a computer engineering degree than just build computers.
Yeah, absolutely. That's fascinating. Like, so at BU at that time, how many computers were there on campus?
You had to go into a basement. So that old stereotype of, being an engineer or programmer in the basement, we actually had to go in the basement, but you had to share. Back then you had like one mainframe the size of a coffin or two, and you had to share this computer with, other users. So you just connected via a terminal, and we used to have to wait in line, sign up and wait in line for 45 minutes to get in that terminal. And then they'd time you out back then to say, well, you've been on, you got to give somebody else a chance. So it really was, not just you had to be interested, but you really had to wait in line. It was almost like waiting for the newest, hot topic toy to come out that you had to wait. And I did that for many years. And so when personal computers came out, I was like, what? I can have one in my own house. That was amazing.
Yeah, absolutely. And I mean, they still are just these magic little boxes, right? That perform basically any task that you can possibly ask of them these days. When did you first come across computer vision? And how did you decide to go down that route?
So it was kind of interesting because when I first came to Tufts, that's when I had to start, embarking on a research program. So I came from industry, which in itself was an anomaly for most faculty. So I came to Tufts and I was the only woman in electrical and computer engineering. I had no female students, and they said, you're hired to be a mentor for women. Unfortunately, there were no female students. So while I was there, I was trying to think about what kind of projects could I bring and look at. And so some of the research problems I was looking at, everybody kept looking at problems and saying, well, a human would say this, or a human observer would say that. And they were trying to emulate that on a computer. And my first interest was, well, why, if you want to emulate a human, why don't you model the way humans see? Yeah. And just as a simple example, a lot of the image processing algorithms that were standard and out there used linear arithmetic. Well, your human eye is logarithmic. So I was like, that to me was common sense. So I came up with a way to have computer vision determine automatically, without a human in the loop, what a human eye would say, this is the best quality image. And that was pretty, groundbreaking at the time. And especially for somebody who was a computer architect coming into this field where other people had been in this for decades. And I was like, who is she? Where did she come up with this? And it was straightforward and simple, which I think threw salt in the wound, because it was like, why didn't I think of that? Well, they didn't have that perspective.
Yeah, absolutely. I mean, talk about how the input and perspective of somebody coming in from the outside and with a totally different, version of reality and of gender and everything else that you're coming in from, how that lens gave you the perspective that you needed to do something really revolutionary. And it sounds like, it wasn't necessarily an idea that was met super openly by your peers to begin with.
Yeah, but Abby, you're absolutely right, because that was the impetus for me to show why diversity and different perspectives can contribute to making impactful innovation, and that your imagination really contributed to that. So that was a huge, barrier that I just introduced, was like, well, I came from this different perspective of the digital logic world, and here's the efficiencies that I don't see these other fields of image processing even leveraging on. And by the way, women are totally neglected in this equation, yet at that time, 90% of all minivans were being sold to female customers. And it was like, but the dummy that they did the crash test with were modeled after a guy. And that was another one. Was like, you're missing the point. You're missing a market. Even toys. When I had my son, I saw that the toys that were out there for boys were very mechanical, very, engineering wise, but yet from when I was a kid, it was still the nurturing, the dolls that, you change, you feed, you clothe. And I was like, wow, that hasn't changed. So that's where I started thinking about gender equity and how we deliver engineering curriculum.
That's really interesting. And so, I mean, you took a lot of this perspective, and it seems like you spot problems across the board, right? Every time that we talk, I'm always so amazed by the amount of problems that you see, and you're like, I can solve for them. And so you started out with applying some of your expertise to a wide range of applications. So you started with color and image enhancement, right? And then you moved on to detection at the edge. Then there's some biomedical applications and autonomous vehicles. At the end of the day, how do you decide what to work on first, or how do you prioritize all of these different applications?
It's actually very straightforward. It sounds complicated, but it's very straightforward. I am totally motivated by what I see out there socially, social problems. So I get into firefighting because I see people can't see through smoke, or search and rescue. I got into biomedical imaging because I see how many people are misdiagnosed. And so the way I usually frame it is I come up with engines and then I put them in different vehicles. Yeah. So that engine that I use is a combination of, now it's artificial intelligence and simulation, an image enhancement. I put all these pieces together to build a different vehicle. So right now, yes, I can detect wrong way traffic and kids on bicycles versus somebody in a motorcycle, because or deer. It started out as a conservation project. I can do deer detection. I started out doing elephant conservation.
Yeah,
So it's a
absolutely.
different application, but always at the core, the same engine, just tuned correctly for that application.
That's great. And so you've got this engine that could be used to motivate or drive change in a variety of areas. And then it sounds like you decide what to prioritize or where to use it next based on true need, right? An
So
actual.
when COVID hit,
Mhm.
I was already working on biological image processing and AI. So we were one of the first of here to come out and say, well, you know what, let me see if I can do an automatic detection of COVID in x-rays and distinguish it from viral pneumonia. And now we're looking at, that's not good enough anymore. We want to be able to tell the severity of it so
Yeah.
that we'll know who's going to be hospitalized. So it shows you that we can just, pivot using, again, the same engine.
Yeah, absolutely. Okay, so out of all of these projects, what's been your favorite one so far?
I think that the ones that I've done for conservation and for
Mhm.
saving lives, like for the firemen, as well as for traffic management, are probably the ones that I see the most immediate impact on.
Mhm.
I've done projects on autism for young girls in India. And those, wherever you have to come over, I don't want to say a cultural barrier, but get acceptance through populations and things like that. Those take a lot longer for acceptance and adaptation. But I think that some of the things that we've done immediately for firefighting, the first responder community has just jumped all in,
Yeah.
because here's the people that put themselves at risk every day. And while the technology is there, it's too expensive. It's not working in real time. And we've got these solutions. Or that we see children or people die in highways every day from people under the influence because you don't detect these incidents fast enough. And those are problems that we're solving.
Yeah, absolutely. It must be so nice to be able to see like an end result that leaves the world in a better place than it was when you started your research within like a shorter period of time. I guess what drives you behind that? There's so many people in this world who take their skills and they use them for something that, nothing wrong with this, but make them lots of money or that, improve different aspects of things. But why do you think it's so important to you to use your skills to improve the world that we live in?
It's so funny you say that, Ab, because every time I say, Daddy, I'm working on this new blah, blah, blah project, he say, is this going to make you money? What money are you getting? You're going to, you're advising the president of Malawi. What are you going to do in Malawi? You're not going there, are you? How are you going to help people in a different country? So making that connection, to him was always like, why are you doing this? And I think that most of it is because I want to show it's really not been about me. It's been about how can I be the best educator and role model for my students.
Yeah.
They're my legacy.
Yeah.
And if I can empower them to change the world, and usually most women drop out of engineering
Yeah.
because they don't see the social impact that they can make. And,
Yeah.
and especially in my field of electrical computer engineering, that's still the most least representative field of cross engineering. But if you can connect those and show how your perspective, your skills can make a difference. And we did exactly that. I had a young lady who was only in her second year. And when 9/11 happened, I happened to be working on a high-speed communications device for one of the companies that manufactures the cellular communications. And they called me and they said, we're going to manufacture your device in the next 48 hours. We need to deploy it to New York City to bring back communications to the first responders. And, I panicked, and here's my student that was doing the modeling. I'm like, it's going to be fabricated, and it worked. We brought back communications to New York City. And when I finished with her, I said, did you ever think that you'd be working on something so impactful? And she said, I never thought anything I learned in your class would be useful. So that's the other thing is young people, they think they're learning these tools, but they don't see the big picture. And, and in 48 hours, she saw the big picture.
Yeah, that's fantastic. You mentioned a little bit about how when you first got into the field, you're the only woman on the faculty. You didn't have any women in your classes, and still there's such a minority in the field. Have you seen any growth at all in the kinds of women who are interested?
Sure. So right now, a lot of the barriers are coming down because
Mm,
it used to be that you had to be this one-dimensional, the math, the science. We put these filters on youth
yeah.
at very young ages saying, if you're not the very best at math and science. And to a young lady, that means I got to get A pluses. And even when they get that grade, they still think it was luck. I don't know. I don't really feel like I know it. Where if you say that to a young guy, he might say, yeah, I got a C. I'm doing fine.
Yeah.
So there's these different, thresholds. And then the other piece of it is, we had for the longest time, the projects were not gender equitable. And I always give the example as if you go into a classroom and you say, today we're going to design high heels. And you said that to boys and girls, you're going to get parents calling you saying, I don't want my kid to design high heels.
Yeah.
But if you say we're going to design sneakers, now you've made gender equitable because everybody loves sneakers. And that's been the predominant barrier. And then the other piece is that young ladies think, well, I can't be a cheerleader. I can't be singing. I can't do sports. For the longest time, when I first introduced the Nerd Girls program, I got accused of casting the girls. And I was like, no, these are students. They really, because they thought that to be an engineer, you have to look like, someone who's socially inept and unkept. They were sports writers. They were, gymnasts, ballroom dancers. And that's really the richness and depth that we have to show the world that this is really what you need to make the most impactful, innovative engineers of the future.
Yeah, I highly suspect that most of the male engineers out there weren't told by their fathers, well, because you love fashion so much, you better get a good paying job. So I can only imagine what it was like not only to be like one of the first women in the area, but also to be one of the first women who cared about something more than just, the code, that saw like a bigger picture and that like loved to do it dressed stylishly.
And that's the other thing too, is, I showed up before Pretty in Pink or before the Legally Blonde movie came out. And I came in this pastel pink suit with matching pink shoes and immediately, what you looked like was, okay, she can't be technically sound. She can't be scholarly. And it was amazing that the stigma and the bias that came with just being an individual. So I was really shocked by that. And I think now that we understand that it's like, what, it doesn't matter how you dress. You can be any way and express yourself any way you want. It's really what you bring to the table. But you hit the nail on the head. It was quite a challenge. And I think that that's really another myth, was that they hired me thinking that all women are nurturing and we're all by nature excellent instructors. So it's like, yeah, I guess, they were lucky. I was,
Yeah.
but I had never taught a day in my life. And nobody trained me. I got no mentoring on teaching. It was like, here's your textbooks, here's your classes. And by the way, here's 90 students.
You're a woman, you're going to be good at this. Well, I love thinking of you as like the Elle Woods of engineering. That's definitely like the picture that I've got in my brain at the moment. And I know you mentioned a little bit how you went into this new teaching position, even without any experience or without any training or coaching on how to be a good one, thinking about how can I rewrite the educational curriculum in order to be more inclusive. And one of the things that I saw with Nerd Girls that you've done is you talk about creativity in it. Mm-hmm. And as you mentioned, like we're brought up to think that like we're a left brain thinker or a right brain thinker. We're, a scientist or engineer, or we're an artist and, a fashion forward mm-hmm. person. Why do you think that it's so important to talk about creativity as part of STEM?
Because you can't come up with innovation without imagining things that don't exist. So if you put yourself in a box and say, no, I can't go to the moon. No, I can't be an astronaut. No, I can't come up with a new medicine to conquer, these afflictions. You have to be able to not be intimidated, even when other people think you're crazy. So I'll give you an example, asteroid mining. Right, for resources or making jet fuel out of water in space, or to reduce the load of payloads, to do mining and set up manufacturing on the moon. people hear this and they think it's science fiction. It's like, you know what? It's really not. There is progress and there is research going on there. And yet it took someone courageous and creative enough to even put that idea out there, where, and acceptance has not come easy for new innovative ideas. So, the example I always give about bringing the female perspective is, when there's in military, they put pantyhose over the guns and the things to keep the sand out when they were doing some, had some issues. And I was like, do you really thought a guy thought of that? How many guys use pantyhose? Maybe today I'm being biased and maybe they do, but that's an example. And even if that it resonated with me, because even in high school, when we were doing projects, I used pantyhose in my design, and that, everybody giggled and laughed at me, but mine worked and it was flawless.
Absolutely. Well, and it's such I guess it ties a lot back into like our initial conversation around perspective, even, right? Like even coming in to attack something as large as like computer vision and saying like, hey, wait a minute, that's not that doesn't sound like the right way. Like you're using creative thought in order to figure out a way to connect the dots between two things that people had not otherwise hadn't connected the dots between. And so it's really great to hear that you're thinking about creativity in that way. Another example that I love is I talked to a friend of mine who's a plastic surgeon and who actually had been an art student as their minor in college. And when I asked her about it, she said, well, how in the world am I going to be able to design somebody's face, right? If I can't actually draw, or if I don't have like any artistry in me whatsoever. And so the marrying of the two, I think, is incredibly important to recognize how creativity just has a major role in STEM as a whole. If you had to give a piece of advice to women who are looking to break into the field today, or, what do you tell your students the first day of class is a big thing for them to focus on and concentrate in order to be successful in this field? What's that piece of advice?
Well, I have multiple, but the first one is get ready for failure, because if you think you're going to get everything right the first time, we always think our career paths are going to be this beautiful linear line, and it's a zigzag, right? It's up and down. And I think that that's another myth we need to break. Engineering is about learning from failure, because if we fail early and often before it gets out to the intended audience or people that we want to use it, then it's going to be more robust. And that's another thing that drives women from engineering is they fail, or an experiment fails, or something didn't work. And I always say, if you play sports and you're on a team and you lose the game, do you quit the team and the sport? And the answer is no, right? You train harder, you're smarter, and you try to learn from those around you that have skills you don't. And engineering is the same. And the other piece of it is, what is it that is going to get you to the next level? And it's really surrounding yourself with people who empower you. You can always find somebody to shoot holes in your ideas or tell you you're crazy. Every patent I have is somebody has told me I'm crazy. So now when I propose something and they say I'm crazy, I'm like, there's my next patent. And I think that that's important, is that for women, we look for affirmation sometimes from people that we admire. And even if you admire them, that doesn't mean they're going to empower you. Yep. So I always say, if somebody tells you you can't, or you're not good enough, or you'll never do it, or that's a crazy idea, I usually say kick them to the curb. I know that's not an eloquent way to say it, but I do. I kick them to the curb, move on, find somebody else that's going to empower you. And you might not find it in your organization. For me, I had to reach out to the professional societies like the IEEE to get that camaraderie, to get the mentoring that I couldn't get because there was no other women to mentor me. Yeah. So I got that outside, and you have to be resourceful enough to say, you know what, I'm missing something. Where can I get this? This is what I need, or I don't even know what I need. Who can I talk to? Reach outside your organization. Don't stop at the people who just say, no, you can't, or we don't have that here. We don't have the capacity to spend this time with you. So, always, nobody knows you better than you. So don't let anybody hold you back. Otherwise, I would not have been anywhere near where I am now today if I had listened to them.
Yeah, that's such a great point. I'm totally with you that I think as women, we like to look for affirmation, and like we I think we make decisions a lot differently than men do, and that we go out and we ask, like, well, what do you think of this? What do you think of this? What do you think of this? As we build up consensus, or we build up like a thought around it. And it sounds like IEEE has been like one of those groups for you that has just been really imperative in helping you make decisions. Tell me a little bit about IEEE and the women's group that you run there.
Sure. So I joined IEEE, oh my gosh, when I was a sophomore in college. No, I came in I was graduate, I was in a downturned economy, and getting jobs was the same 5 people from the class were being interviewed for every single job that came out. And it was like, what about the rest of us? So I joined the IEEE, and they sent a gentleman from Ohio to come in over a weekend to do a student professional awareness conference. And that's where I saw, like, wow, look at the way he speaks. And I learned, that's another thing. If I want to teach, this is an example of somebody I want to be able to lecture like. He's so impactful. But he believed in us. He didn't even know us. And he's like, you know what? You're in IEEE, you're in engineering. You had enough gumption to dedicate your weekend to your professional development, to be here when you could be out having a good time somewhere else. He says, you're all going to make it because you're showing the potential, just the fact that you've vested in yourself. And I kept in touch with him. I joined, and I became leader in my Boston section. And then I became the worldwide director of women in engineering. And then I came up with the magazine, the idea of the magazine, to tell the stories of creative women making impact all around the world, women that escaped political prosecution, or from cultures where women weren't supposed to be in engineering, or just they were really confined to the cultural norms of their backgrounds. And telling those stories and sharing them is impactful. But the other thing I found about that was it shows that we're not alone. We always feel that we're isolated. I love Harry Potter, for the magic, but there's also a line in there where he feels that the world's against him. And somebody said it to him, Luna Lovegood says to him, that's because you're not as much as a threat if they think you're alone. And that's why I think women in engineering help, because it showed, we're all experiencing the same story over and over. It's not just me who's experienced this, but millions of women around the world. This is something that we need to talk about rather than just internalizing it. And how do we solve it together? And that's exactly what we've been doing, is empowering and solving these challenges together, because we are a triple threat if we're in numbers.
Absolutely. Oh, I love that. All right. So one fun question that we always like to end the interview on is, if computers didn't exist at all, what do you think your career choice would have been?
Oh, I know what it would have been. I would have been in music. I would have been, I'm a professionally trained opera singer. Wow. I would have loved to have been on Broadway. I would have been dancing. I would have been, I would have been either a Madonna, cross between a Madonna and a Sarah Brightman type of person.
So basically what you're telling me is that in college, instead of choosing the stage, you chose the basement.
Yeah, and as a matter of fact, and it's funny because my voice teacher, she trained with the Metropolitan Opera, and she said to me, when comes time, will you give up the engineering? And I was like, in a heartbeat. And
amazing.
Yeah, but then my dad was like, no, you're not making any money at that. So so that sort of killed that. But I'm trying to inspire that, love of music with my own child, and hopefully financially, I think that sometimes all of us grow up thinking we're financially constrained to do the right thing to support ourselves. And sometimes we sacrifice our creative passions for that. And I haven't had to sacrifice a lot of my creative passions, but I feel that I didn't get to fully explore them either.
Yeah, well, absolutely. I mean, I think that the world is a much better place because of the time that you have spent engineering. So hopefully that gives you a bit of solace, and that you'll find all of those creative outlets as fun things to do after you've improved the world with all of these amazing applications of engineering. Thank you so much for taking the time to chat with me about the magic of engineering today and in computer science. Really appreciate it, and look forward to talking with you more in the future.
Thank you so much, Abby. It's been so much fun.